Hi guys, let us move on to example problem number 5. It's a three solid combination problem. Following figure shows the front view of combination of solids consisting a cut sphere, the frustum of cone and square pyramid. So square pyramid at the bottom, the base is square of 90 mm. So I take continuous line, a thin line, base 90 mm, 30 degree, 90, 150, 90 minus 150, 90 minus 30. Then I take axis from the center of these two. So this is the center of the base. The height of the frustum of square pyramid is 30 is given. So 30 mm, 90 degree. Keep control, select the base edges and move from base to the top of the frustum of square pyramid and do the scale. The top of the square pyramid is 70 mm. So 70 divided by the original we had 90. That would be the square scale factor and choose the end point. So now this length is 70 mm. Join the corresponding edges of the square pyramid. And trim the unwanted invisible edges. Now we have a frustum of cone. The base is 70. So anyhow we have drawn the square of 70. Let us construct ellipse here itself using midpoint method. Join the corner to opposite midpoint. Take arc by center point method and draw the arcs. This is the radius for a first arc. This is the center. This is the radius for a second arc. The intersection is the center. This is the radius for third arc. And finally, this is the arc. Now the height of the frustum of cone is 40 mm. He has given 40 mm. So take axis line from the center of this, from the end point of the previous arc. Let us take 40 mm, 90 degree. The top of the frustum of cone is dia 60 mm is given in the figure itself. So dia 60, I choose the ellipse, bottom ellipse. I go for move command and move it from base and place it on the top of the axis and go for scale. The needed ellipse is 60 divided by already we having 80 mm dia of base. So 60 by 80 will be the scale factor and choose the top end point of the axis. So this is the top face of this frustum of square pyramid, sorry, frustum of cone, and join a tangent line. Above this, a cut sphere will come. The sphere radius is 30. So take axis line from this endpoint, take 30 mm, 90 degree. Further, it's a cut sphere, it's not a hemisphere. So what we arrived is the radius, sorry, center of the hemisphere. So 10 mm above the sphere has cut. So 10 mm extra 10 mm 90 degree. We need to take one more line, two lines, 30 mm 90 degree and 10 mm 90 degree. So to find the center, the size of this ellipse, we need to draw a circle by center point with radius 30 mm. This is the radius 30 mm. And draw a line from the center 10 mm 90 degree. Draw horizontal line from there. Trim the unwanted edges. Find the distance between these two endpoints. Why? Because if you trim this hemisphere, this is what the cut sphere. So if you trim that arc, what you arrived is hemisphere. Sorry, cut sphere. So from this endpoint to this endpoint, the dimension you want 56.57. Anyhow, now you have the bottom ellipse. Select the bottom ellipse, which is of size 60. Go to move option, choose it from the midpoint and place it on the top, the last, and go for a scale. The scale factor 56.57 divided by the original we had 60 and place it on this endpoint. Now we need to go for a circle by center point. The center point will be, you should be very careful while choosing. For your reference, I will take dimension. See, we have taken 10 mm line here and 30 mm line here. So that this center, this is the point for the circle. This is the center, not at the top. This is the center, and diameter or radius you can give 30 mm of sphere. Now take a trim command and trim the unwanted edges. Take trim. It should look like a cut sphere. Trim the unwanted edges. So this will forms the cut sphere. Delete the dimension. We will not do dimensioning for isometric, and trim the unwanted edges also. These are going to be invisible. Trim the invisible edges. Select the entire diagram and make it thick, but the axis must be thin. 0.13. So this is the solution for the example problem number 5, and we need to take scale for entire thing. Take scale 0.8164. This is solution for problem number 5. Let's move on to problem number 6. The frustum of square pyramid of base side 40 mm, top face 20 mm, and height 60 mm rest on center of top of square block of side 60 mm and height 20 mm. The base edges of the pyramid is parallel to the top edges of the square block. Draw the isometric projection of the combination of the solids. So let us draw the first solid, that is top square block. So square block of side 60 mm and height 20 mm. So side 60, 30 degree, 60, 150, 60 minus 150, 60 minus 30. And draw the thickness 20 minus 90, 60 minus 30, and this line will be 60, 30 degree, connect to the end point. Now from the center, you measure the axis. Take axis line. The intersection of these two will be the center of the square block. From there, you take height of the frustum of square pyramid. Height is 60 mm. So 60, 90 degree. Let us choose the bottom square. The base of the square pyramid is 40. So I go for move, switch on copy. From center, I'll place on a center itself, but I take scale of size 40 divided by 60. So this is the 40 mm square I will get. And at the same time, I take scale once again and switch on copy option. From center, otherwise we can go for move. From center, we place it on top of this and go for scale. 20 is the top face side divided by 40. Place it on this end point. Join the corresponding corners. So this is also the corresponding visible line. Trim the unwanted invisible edges. Finally, choose the entire thing, give it 0.5 mm thick, and take scale 0.8164. So this is the solution for example problem number 6. Problem number 7, example problem is a square pyramid of base side 40 mm and height 70 mm rests centrally over a cube which itself placed on cylinder. So it's a three solid combinations. So base you have cylinder. Let us take a cylinder of diameter 80 mm. So 80, 30 degree, 80, 150, 80 minus 150, 80 minus 30. Construct an ellipse at this box. Draw the arcs, the first arc, the intersection. The intersection is the center, and this will be the radius. And final arc, this is the center, the midpoint is the radius. Then the thickness is given. The thickness of the cylinder is 30 mm. Let us take an axis line. The center of this box is here. From there, 30 mm, 90 degree we take. Choose, keep control, choose the ellipse and just move with copy from base to the top end, base to the top of this axis. So this gives you the cylinder. Now above this cylinder there is a cube of side 50 mm. Cube of side 50 mm. I can take these four edges as a reference. Is 80 mm. I'll move this from base center to the top of the select the bottom base 80 mm square, move that from center to the top end and give scale 50 divided by the original was 80 and place it on this end point. So from that you take height of the cube. This is the base of the cube. What we got, height of the cube is 50, 90 is a thick line, a continuous line, and select the base of the cone, base of the cube, and move with copy from base to the top and join the corresponding corners. And join a tangent line 2 to show the cylinder. So the cylinder with cube is ready. Now we need to draw the square pyramid of base 50 mm. So anyhow, we have a square of 50 mm side here. Let us move that from the center and we'll place there itself and give scale 40 divided by 50 and place exactly at the center. Now show the axis from the center is the center. Axis is 70, 90 degree. Join the corresponding corners with the vertex, apex. Trim the unwanted edges, invisible edges. These are going to be invisible. You can make use of zoom also to give a perfect finishing. So the solution is completed and you need to take scale for this drawing. The isometric scale we need to take. So isometric scale is 0.8164. And give a thick of 0.5 mm. Axis line must be thin. So this is the solution for example problem number 7.